In this video, we will see how to install code-ready containers on a remote virtual machine. Code-ready containers have been specifically designed to provide the ability to run OpenShift cluster on a local laptop or personal computer specifically for the development and testing purpose. However, with time, you will notice that the amount of resources that are required to run the code-ready containers might become really high. For instance, in my case, most of my workload deployments into code-ready containers were failing after a point in time due to the lack of sufficient amount of memory and CPU in my laptop. So I had to resort to the usage of a virtual machine which has sufficient amount of memory and CPU resources, and in this demonstration I will be showing how I was able to do that on a remote virtual machine, specifically running the Ubuntu operating system. As you can see from the documentation, running the code-ready containers on Ubuntu is not officially supported and it might require some manual setups on the host machine. And in this video, it is exactly these different sets of manual setups that are required for running the code-ready containers on Ubuntu 18.04 is what I will be showing. And in order to show this setup, I have created a set of cheat sheets, and I will be using these cheat sheets and the steps that are covered in these sheets for this demonstration purposes. Alright, let's get started. And I will be provisioning the virtual machine on the Google Cloud platform. So we will be using the Google Cloud platform in order to create the virtual machine first, and then we will be installing the code-ready containers on top of that specific virtual machine that we would be provisioning. An important aspect that we need to remember before we create the virtual machine is that the virtual machine should have the nested virtualization enabled. After all, the code-ready containers relies on the libvirt to be able to run it on any of the operating systems. So first, what we would be doing is we would be creating a disk which is based on the Ubuntu operating system, and we will use that disk to create an image that has nested virtualization enabled, and finally we will use that image to create a virtual machine instance, and that is what we are going to do now. So in order to create the disk, first let's go to the G-Cloud console and let's go back to the cheat sheet, and let me take up the first command here, which is going to create a disk that is based on the Ubuntu 18.04 operating system. So let's create the disk. So I have named the disk as CRC disk. So the disk creation is happening. So the disk has got created and it's in a ready state. Now we will use this disk to create an image, and that image we will be enabling the nested virtualization by applying suitable licenses. So what we're going to do here is use this specific disk called CRC disk and create an image which we are going to name it as CRC v4 image, and apply the licenses so that the nested virtualization gets enabled on this particular image. So let me take this command and execute it here. Now the image creation is happening using the disk that we had created in the previous step. Let's give it a few minutes. Alright, the image has got created. Now we can use this image that we had created with nested virtualization enabled, and we can create a virtual machine using that. So let me close the G-Cloud console. Let me go to create a virtual machine instance, and let me give a name for this virtual machine. So let me name it as CRC virtual machine, and for this demonstration purposes I'm going to choose the machine family as N1 standard 8, which is going to provide us with 8 vCPUs and 30 gigs of memory, and the boot disk is something that I am going to change here to custom images. and we would be using the nested virtualization enabled image that is based on Ubuntu 18.04, and we will create the VM instance using this particular image. I'm increasing the size of the boot disk type to 100 gigs. Let me select that, and let's enable the full access to all cloud APIs and allow the HTTP as well as the HTTPS traffic for this. And let's create the virtual machine. So the machine has got created now, still getting created. Let's give some few more minutes for it to get completed. Now that the virtual machine is ready, let's SSH into that. Now let's start with the installation of the required set of packages. So let me go back to the cheat sheet, and the first step is to install the libvirt and the DNS mask packages. So let's do that. Let's do an update first, and then we can do the package installation. Let's run the update first, and then the installation of the libvirt as well as the DNS mask packages. Alright, so now we have got the required set of packages installed. Now the next step is to add the currently logged in user to the specific set of groups, the libvirt groups. So let's do that by using these three commands. I'll issue these three commands one after the other. Alright, so the user has got added. Let's check that out. Alright, the user currently logged in user has got added to these three groups. And now let's do a reboot in order to ensure that the correct access privileges are applied to the logged in user. Let's do a reboot and do a reconnect. After the reboot, let's go back and look for the next set of steps. So in the next step, we would be informing the resolved that we would like to use DNS to be able to run in parallel with resolve, and we will also be specifying the domains, the CRC domains that are required. So let's take this up and edit the resolved conf accordingly. Alright, now let's change the listen address in the DNS mask configuration to point to the DNS IP address that we had given. So let's do that. Alright, and let's just check if it has got set correctly. Alright, it has got set correctly here, as we can see that. And the next step is to specifically switch off or to inform the DNS mask that it has to ignore the resolve configuration by using this parameter ignore resolve conf to yes. So let's make this setting now. Alright, With that done, the next and the last important step is to inform or to provide the CRC configuration to the DNS mask. So let's do that now. With that, we will restart both the resolve D and the DNS mask so that it can pick up the required set of configurations. The changes that we had made just now will get picked up after the restart of resolve D and the DNS mask. Let's wait for that. And now that the restart has been done, let's check if we are able to reach to these domains specifically that we had configured. Yes, this is reachable. And let's check for the other domain as well, the CRC testing. Alright, so both of them are reachable now. And the next step is to just go ahead and download the CRC setup and install it. So I have provided all the required commands in this single command line. So let's execute it. First it will download the CRC, the latest CRC package. It will extract it and it will create a specific folder and it will move the specific installer, the CRC installer, to that folder, and after that we will be able to use the specific installer to continue with the setup and installation. Alright, this is done. Now let's go ahead and configure the CRC. So since we have done these manual steps before, we will be informing the CRC that we don't have to check, we don't have to do some specific checks. So we will set the skip parameters for those checks that we don't want the CRC to do. So these are the 4 different checks that we have skipped in the configuration. And let's do the CRC setup now. Okay, so then the next step is to directly go ahead and start the CRC, but before we do that, we need to have the pull secret for the CRC setup, and that could be obtained from this particular URL. So I have already downloaded the CRC pull secret, and so we will be using that pull secret directly here. So let me upload the pull secret. Just got uploaded and it's available for usage. So let's go ahead and start the code ready containers. And in here, for example, since my virtual machine has 30 gigs of memory, I'm allocating around 20 gigs for the CRC so that it can really take the available memory and provide it for running my workload on top of that. And similar to the memory configuration, we can also specify the amount of CPU that the CRC can use here, if in case that is required. So for now, I'm not specifying the number of CPUs, I'm just specifying only the amount of memory that has to be allocated for CRC. And by default, CRC would be using, I think, 4 CPUs. Alright, so CRC start has got triggered. So let's have a look at the logs to see what's happening. The bundle extraction is going on right now. Let's give it a few minutes so that it can do the bundle extraction. Alright, now the OpenShift cluster seems to be starting. We need to wait for a few minutes for it to be up and running. Alright, so the instance has got created now, and we should be able to access it using the credentials that we can see here. So let's try that out. Let me log in as an admin and see if I'm able to connect to the CRC instance. Alright, so the CRC command is not found. This is because we need to set the OCANV for the CRC. So let's do that. Alright, now let's issue the OC command and log in. And yes, we are able to log in to the CRC setup, and we can see the default set of projects that have got created with CRC. Now we have the CRC up and running. Now the important aspect about using the CRC is that it provides a very nice developer console. So now let's see if we can access the developer console that's provided by CRC console. Unfortunately, we are not able to open it because this is a remote virtual machine. So let's try to install a desktop environment in this virtual machine and try to connect to it using the remote desktop. So let's do that now. And in order to connect to, or in order to install the required desktop environment, let's go back to this cheat sheet and let's start with the installation of the Google remote desktop client. So these are the commands. First we will download the Chrome remote desktop client, and then we will install it using the next set of commands. So let's do that. Download, update, and install. Okay, so the Chrome remote desktop has got installed now, and as a next step, let's install a very lightweight desktop environment on this VM using XFCE. So let's do that. So in here we are specifically mentioning about the installation of XFCE 4, and then we also create a specific configuration for that, and finally we also install a screensaver. So let's execute these commands and wait for the installation to be completed. We're almost there. Okay, So the desktop environment and the screensaver installation has got completed. And as the last step, let's also install a Chrome on this virtual machine. So let's do that. First we will download the Google Chrome, and then we will do the installation. Now the Chrome installation is also complete, and as a next step, let's try to connect to this CRC instance. Given that we already have a desktop environment set up, let's do a remote connection and connect to it so that we can see the CRC console on the browser. And in order to do that, I would be using the remote desktop from Google itself. So let me go to the Chrome remote desktop and let's set it up. So let's go to remote desktop, headless, and begin, and let me go to the next step. Let me authorize my user ID. Alright, and then I've got the required set of commands that I need to execute on my virtual machine so that I can connect to it using the remote desktop. So let's go back to my virtual machine and provide this command and execute it. So let me give a name for this computer and a pin as well, which is what I would be using later to connect to it from the desktop. I think okay, it should be 6 digits. All right. Okay, so the remote desktop connectivity has also been done now. So let's go back and try to connect to it. So in order to connect to it, we will be using the access URL on the remote desktop. So let me go to access, and I will switch back to the right user ID using which I will be making the connections, and we can see that the specific machine that we are trying to connect to is already online, is shown as online. So let's try to connect to it, and it will ask for the specific pin that I had configured on the virtual machine. So let me provide the pin, and here we go. The desktop is ready now, and we can access the CRC console from here. So let's go to applications, internet, and we also see the Chrome that we have installed is also available here. Okay, and let's go back to the VM and let's get the CRC console credentials. Alright, so these are the credentials, and let's get the CRC console URL as well. So this is the URL. So let's go back and provide this URL here. Alright, I think it has got copied. Just copied the entire sentence. So let's take that off and let's accept the security warning here. And finally we have the CRC console accessible for us. So once more, let me accept this and let me log in as Cube admin, and the credential for that, let me take it from here. And we can see that we are able to log into the CRC console and we can go and have a look at my favorite, the developer console here, which shows the topology of the specific project that I selected. And with this, we have come to the end of this demonstration, and in one of the next videos I will be showing as to how we can connect to this remote virtual machine, the CRC instance that is running on this remote virtual machine from the laptop, so that we get a seamless developer experience for deploying the workloads from the local laptop to the remote virtual machine. Thanks for watching.